Now these are examples of figures where we're adding areas together. However, there are cases where we have a shape where we're actually taking areas away. So what I'd like you to do, rather than move on to the other examples, we'll actually be doing those in class, is I'd like you to go ahead and turn the paper over, and we're going to take a look at example numbers 5 and 6, which you can see in your notes. So we're going to take a look at example numbers 5 and 6, which you can see in your notes. Now example 5, we're asked to find the area of the shaded region of the circle, but notice that inside of the circle, we've removed a square. The way that this is going to work is we're going to consider the area of the shaded region, we'll call it the area of the shaded, is going to be equal to, well, in the instances before, we took areas and we put them together. In this instance, however, we're going to take areas and we're actually going to remove them from other areas. So the whole circle represents the template for the area. So that's the area of the circle. I'll call that a circ. And we're going to subtract the area of the square. Because the area of the shaded region is equal to the area of the circle minus the area of the square, which we've removed from that circle, like a cookie being cut out of dough, for instance. Good. So, the circle actually is pretty easy. Remember that the area of any circle, and I'll go ahead and I'll start with that. The area of any circle is equal to pi r squared. In this case, the radius, well, if 6 inches represents the whole distance, the radius would be 3 inches. And so the area of the circle is pi times 3 squared. Because we can round to the nearest tenth, you can write your answer as 9 pi if you'd like, or you're welcome to write it as a decimal, which in this case works out to be 28.3 inches squared. So that's the area of the circle. To find the area of the square, we actually have a little bit of work cut out for us here. The reason why is because we don't know the side lengths of the square. But fortunately, we do have something that can help us, and that is our good old friend trigonometry. Or even not even trigonometry, actually. In this case, we would just use 45, 45, 90 triangles. Notice that in a square, we have a right angle. We know that because this is an isosceles right triangle, this is 45 degrees, and this is 45 degrees. And so we end up in the exact same scenario that we were in the last chapter, where we're trying to find the side lengths of a 45, 45, 90 triangle. And so in this case, if we know that this is x, and we know this is x radical 2, we set 6 equal to x root 2. And we find out that that side length is equal to 6 over radical 2, which remember we have to rationalize to become 6 root 2 over 2, which eventually reduces to 3 root 2. So that represents the side, 3 root 2 inches. Now I'm not going to turn that into a decimal. I could, and I would still probably get the right answer. But I actually want to leave this the way it is, because to find the area of a square, which I'm going to do now, and I'm going to need a little bit more space, so I'm going to cheat over a little bit here, and then I'll erase it later. So to find the area of the square, remember that I'm taking one side of the square, which in this case is 3 radical 2, and I'm going to multiply it by another side of the square, the base times the height, which is also 3 radical 2. 3 times 3 becomes 9. Radical 2 times radical 2 is radical 4. And then 9 times radical 4 is the same as 9 times 2, or 18 inches squared. If you used your calculator for that, you should have ended up with something very close. If you rounded decimal points, you may have ended up with 17.9. Or something very close to that. However, you do want to be careful. In this case, it is actually exactly 18 inches squared. And now that leaves us to the area of the shaded region, which we said was the area of the circle, minus the area of the square. So to calculate that, and I am certainly running out of space here, but I will give myself a little bit of space underneath here just so you can see it. Remember that your notes will always, of course, be a bit more neater than mine are right here. And you end up getting that the area of the shaded region is equal to 28.3 minus 18, which reduces to 10.3 inches, or solves 10.3 inches squared. And that's your final answer for example 5. Okay? Now example 6 is done in the exact same way. I want to go ahead and allow you to give it a shot, so go ahead and try it. In this case, we're taking the area of a rectangle, and we're taking away the area of 2 semicircles. And I'll give you a moment to do that, and then I'll solve it on the board as well. with the solution, and you can check to see that you did the right thing. Tomorrow in class, we'll be going over the entire topic. There it is. We'll be going over the entire rest of the worksheet, so don't panic about these examples yet. We'll be doing those together soon. But I want you to go ahead and give this a shot. While you're working, I'm going to solve this problem. I'll explain it as well, but you may want to pause the video here and try it on your own, and then resume in a moment. So, at this point you may want to pause, and we're ready to keep going. The area of the rectangle, in this case, is going to be equal to the base times the height, in this case 33 times 16, which comes out to be 528 square feet. We have here two semicircles with the same radius. So you can be a bit creative if you want and make one giant circle. Or alternatively, you can sort of take a more honest approach, we'll call it, and do one semicircle and then double it because they are symmetric. They happen to be the same semicircle. Either way you choose to do it is fine. I'm going to go ahead and I'm going to find the area of the semicircles individually. And so the area of the first semicircle over here, well, if the whole radius, or the diameter rather, is 16, then we know that the radius is equal to 8 feet. That's from there to there. And so we go ahead and we do 1/2, because it's a semicircle, pi times 8 squared. When we calculate that, we end up getting 100.5 feet squared, which is also 32 pi, for those of you that didn't want to wrap it. And then we take that value and we double it, because we have two semicircles. And so when you double this, you end up getting the area, so I'll move back to here. The area of the semicircle plus the area of the other semicircle is equal to 100.5 plus 100.5, which is 201 feet squared. And now we're ready to find the area of the final rectangle, or sorry, the area of the shaded region, which is here. Sort of like an hourglass. And we go ahead and we find the area of the shaded region is equal to 528 minus 201, which is 327 squared. That concludes this online lesson, ladies and gentlemen. Your homework, of course, is to make sure that you have these 4 examples that we've done together completely done in your notes. We'll be checking them tomorrow, and then we'll be doing examples in class in this vein. Please feel free to watch the video again if you have any questions. Otherwise, have a nice rest of the evening, and take care.